This lecture will explain the rule of ex falso quodlibet. That's how it's pronounced. It's quad, not quod, like it looks. But we're just going to call it EFQ. Because that's a lot easier. Now your text also, in the proof lab, you'll see a rule called falsum E. That's the same thing. But we're not going to use falsum E in the proof lab for two reasons. One, because the proofs where it appears are the proofs I've assigned for Chapter 5, and we don't have EFQ yet in Chapter 5. We don't have it until Chapter 6 here. So we won't use it for that reason. And then the other very good reason why we won't use it in the proof lab is because it's broken. So it doesn't work. I've informed the OLI people and they're working on it, but it won't be fixed in time for us to use it. So just cross that off your list. Okay, so the way the rule of EFQ works is this. So if you have a falsum, then by the rule of EFQ, you can derive any formula. That's what EFQ, that's what ex falso quodlibet, sorry, I'm having trouble with that pronunciation, means. It means from a contradiction, anything follows. And if you think about it, this makes sense. So, if we have the, how did we get the falsum here? Well, we had some formula P and some formula not P, and then we can do falsum introduction. That's the only way the falsum could have gotten into our proof. So another thing we could have done instead is, instead of writing the falsum, we could have derived the formula P and not P by the rule of and introduction. Well, P and not P is a statement that is clearly false. It's a contradiction, and that's exactly what the falsum means. It just indicates a formula that is always false. Well, it's also the case that the formula P and the formula not P are inconsistent, because it's impossible for them both to be true at the same time. And from any argument with inconsistent premises is valid, no matter what the conclusion is. Because if you think about it, according to the definition of inconsistent premises, these are premises that can't all be true at the same time. So that means if your premises are inconsistent, there's no row where all the premises are true and the conclusion is false, no matter what the conclusion is, because all the premises can't be true at the same time. So that's why any argument with inconsistent premises is valid, and that's precisely what we're exploiting with the rule of EFQ. So again, how the rule of EFQ works is, if we have the falsum, then we can derive anything we want by EFQ. So we could derive P, or we could derive P arrow Q, or we could derive X or Y, and Z if and only if W. We can derive anything we want from this falsum using the rule of EFQ. So it's a pretty nifty rule when we have inconsistent premises. We can just very quickly jump to whatever it is that we're trying to prove.